This video is presented to you by www.testprepadda.com. Dear students, in the previous session, I started the discussion of problems of sets. In this session also, I'll continue doing that. Here the question fifth is, if set of vowels V is equal to A, E, I, O, U and another set S which has elements E, U, M and N, then we have to find V minus S and S minus V. So basically, difference of sets, if I draw the Venn diagram and I take two sets as this V and S. So V minus S is actually a set which has elements present in V but not in S. So you can see E is there in S also, U is there in S also. So I'll select A, I and O from the set V, and this way I get V minus S. So we have to select those elements which are in V but not in set S. Now if I try to find S minus V, this will result into a set which has elements present in S but not in V. So what are those elements? You can see E is there in V, U is there in V, E and U are common elements. So I'll take M from S and N, these two elements. So V minus S has three elements and S minus V has two elements. Now in Venn diagram, if I try to show V minus S, it will be this. V minus S. Now if I try to show you S minus V, it is this. So you can clearly see V minus S and S minus V. These two are disjoint sets. Okay. V minus S is not equal to S minus V. Now I'll take another question here. In this question, four sets A, B, C and D are given and we have to find A union B, then A intersection B, then A intersection B union C, and then A union D intersection with B union C. I'll try to find A union B. This set will contain all those elements which are either in A or in B. The elements should not be repeated here. Now I'll select 2, 3, 5, 7, 9, 11. So these are the elements which are either in A or in B. So this is A union B. Now if I try to find A intersection B, means I need to select those elements which are common to A and B, which are present both in A and B. So what are those elements? You can see 5 is there in A as well as B. 7 is there in A as well as B. 9 is there in A as well as B. So 3 elements are there in this set A intersection B. Now if I try to find A intersection B union C, for that first I'll get B union C. So what is B union C? All those elements which are either in B or in C. 5, 7, 9, 11, 13. Okay, B union C. Now A intersection B union C means now we have to select common elements A and B union C. So what are the common elements? 5, 7, 9. 5, 7, 9. Okay. Now to find A union D intersection with B union C, first I'll try to find A union D, and that will have elements which are present either in A or in D. So 2, 3, 5, 7, 9, 13, 15. Now A union D intersection with B union C. So basically we have to find common elements A union D and B union C. So you can see common elements. 5 is there in both the sets, 7 is there, 9 is there in both the sets, 13 is there in both the sets. So what will be the elements here? 5, 7, 9, 13. Okay, so this way we find the sets. Now I'll take another question here. In this question, a universal set U is given and we have to find complements of few sets like A, B, C. We had already discussed the complement of a set. In the Venn diagram, if I try to show you, if this is the universal set U and A is a subset of this U, then complement of this set A is set of all elements of U which are not present in A, and that means this shaded portion. This is actually U minus A, which we can write as complement of set A. Okay. Now if again we find the complement of this set, then I'll get A back. This is called law of double complementation. Law of double complementation. Now, if I try to find A union A dash, this I get as U. So, A union A dash will have all elements which are there in set U, universal set U. And this is called complement law. Now back to the question. Uh, Set U is given. We have to find complement of this set A. So that I will write as all the elements which are there in U but not in A. So what are those elements? 1, 2, 4, because 3 is there in A, then 6, then 8, and then 10. So 1, 2, 4, 6, 8, and 10. This way I get complement of set A. Now complement of set B. All the elements which are there in U but not in B. So you can see one is there in B, so I'll not select 1. I'll select 2, 3, 5, 6, 9. 2, 3, 5, 6, 9. You can see 8 is there, 7 is there, 4 is there, 1 is there. Now complement of set C. Complement of set C will have elements 1, 3, 5, 7, 9. You can see 2 is here, 4 is here, so I'll not select 2 and 4. 6 is here, 8 is here, 10 is here. So 1, 3, 5, 7, 9. So this way we find complement of a given set. Now I'll take another question here. This question also involves the concept of complement of the set. We have to draw Venn diagrams here. Now if I consider this as the universal set and two subsets of this universal set as A, B, then if I try to find complement of set A, then complement of set A will be, I'll show you, this shaded portion. Now similarly, if I try to find complement of set B, complement of set B, then this is complement of set B. Now if I try to find A union B, A union B, it will be this shaded portion. This is A union B. Now if I try to find complement of this A union B, complement of this A union B, complement of this A union B will be this portion. This is complement of A union B. Now if I try to find A intersection B, A intersection B is this portion. Now if I try to find complement of this A intersection B, what will be that? Complement of A intersection B, it will be this shaded portion. All the elements which are there in U but not A intersection B. So this is complement of A intersection B. Now if I try to find intersection of A dash and B dash, from the shaded portion you can say the common portion is actually this. This is A dash intersection B dash. Now you can see the complement of A union B and A dash intersection B dash, both are same. So I can write A union B complement is equal to A dash intersection B dash. A very important conclusion. Now, similarly, if I try to find A dash union B dash, it will be what? We are aware of A dash, complement of A. We are aware of complement of B. So we have to select those elements which are either in A or in B. So it will be this. You can see the common portion is not there. So except that portion, we have to select everything. So except this portion, we have to select everything. Now you can see this A dash union B dash matches with the A intersection B complement of A intersection B. Both the sets you can see same. That is why we can write A intersection B complement of this set is equal to A dash union B dash. Another very special conclusion. So, what conclusion we can write here? We can say the complement of the union of two sets, the complement of the union of two sets is the intersection of their complements. You can see the complement of the union of two sets is the intersection of their complements, and the complement of the intersection of two sets is the union of their complements. You can see here. So this conclusion we can derive from these Venn diagrams, and actually this conclusion is De Morgan's laws. Okay, so this way we show different Venn diagrams. Dear students, remaining problems of this exercise I'll discuss in the next session. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.